Let's do a bit of programming on the stream today. I am still remembering how to do this in a nice, smooth, efficient way, but that's okay. This is the second day I'm streaming since I've been in Vancouver, so I'm gonna just let myself ramp up in a nice, controlled fashion. And the first thing I'll do is tweet this out just so I'm doing the thing, doing the right stuff. All right, let's see. Let's see. Mm-hmm. All right. Mm-hmm. Okay, so the first thing I want to do is finish messing around a little bit with. I just wanted to double check that my script on the iPad will actually generate step files, and once I know that that works, then I want to probably switch to my Mac and work on some FreeCAD stuff on there just for a little bit of simplicity and figure it out as I go. That's kind of, loosely speaking, the plan for the day. Let's see here. Let's see. Let's do this. Perfect. Okay. Things are more or less working, so that's good. Right. Okay, so let's pop this bad boy open and get some work going here. Oh, this is I have to switch the input here. Let's see if that'll work. It should work. Hey, there we go. Cool. Oh, just gotta let it warm up. All right, we're good. We are good to go. Okay, so what I need to do here is SSH into the Pi. So I figured a few things out. First of all, as far as I can tell, my Emacs setup is actually working, which is pretty cool. So I can actually head into, let's see here, dev, FreeCAD here. want to check as well. Just make sure my stream is streaming. Want to check as well. Just make sure my stream is streaming. Sounds like me, so I think we're good. Let's oops, mute, hide player. All right, now we're going. Okay, so let's have a quick, let's just see. So this is on my iPad right now. I do have Emacs mostly working. Let's try Cider. See if we can launch a Repl and have things work right from the iPad. I tried this a bit this morning. It should actually work, but I'll have to see. One little thing, stream side, I actually want to change here. Let's see. There's a few color issues with this here, right? The color of this border, it's not what I want it to be, but that's just cosmetic. That should be fine for now. Let me see. Did that do what I wanted it to? Not quite. Hope anyone who's tuned into this at any point has a good time. Hey, Mac. Sorry if I'm getting your name wrong there. Hope things are well with you. Sorry, I'm just messing around with my stream cropping here, trying to get rid of silly black bars and stuff. But hey, good to see you. Thanks for the question. Did I settle into my new place? I have. I've been in Vancouver now for close to a month. This is my new room. I've got roommates and everything, which is I've had roommates before, but then I lived on my own in Ontario, and now I moved in with roommates again. They're lovely people. I just have to remember that living with roommates is different than living on your own. My room, I still have to build some things for it, but I'm feeling really happy to be in the city, and I'm glad I made the move. So things are going well with me so far. Hope things are good with you, by the way. I hope things are well. Video of the park was great. It's an amazing place. Oh, well, thanks for checking it out. I appreciate that. That's the next thing I have to change my headspace and like turn to focus to again is making more YouTube videos, because they're so fun and people enjoy them. So I'm happy to do them. But I gotta, you know, I moved, I took a bit of a break. I gotta get some work done again, you know? Gotta get back into that headspace. Things are good here. Hey, glad to hear it. That's nice to know. That is good. So, you brought up the park, the video in the park. In that video, I mentioned wanting to use my iPad. So I actually am on the iPad right now, screen sharing it. And I bought, one of the comments there was talked about how you can actually run an a Raspberry Pi from the iPad and Ethernet connect it through the USB-C. I have done that. I have a Raspberry Pi sitting over there, actually I also bought a new webcam so I can actually move it around now. So on this stack of books, which I haven't cleaned up yet, can I point? Right here is my portable dev station. And I'm just... So the idea is to bring it into that park and work with it offline, right? But in order to make sure I can do that, I have to install a few things and try things out. So I'm SSH'd into it now. It's got a connection to the Wi-Fi while I'm at my place. And I'm just messing around on my iPad, seeing that I can get a reasonable dev environment working. So that's what's going on screen here. Just to try and give you a bit of context. And I'm just now messing around with... I managed to get my minimal Emacs setup that I use on my main computer also working on my iPad. So that's really exciting. And now I'm just kind of messing around, seeing if there's little things that do work or things that don't, and making a list about how to address those things. So that's what's going on here. I'll probably switch over to my Mac to develop some FreeCAD stuff in a bit. But I'm just starting here for fun. Anyway, that's a long-winded talk about nothing. All right, so some of the things highly experimental setup, absolutely. It's a lot of fun though, and like, so I have that I keep calling it an iPad. That Pi, I have it's the 4. It's got 8 gigs RAM. I think it's a 1.5 gigahertz CPU, and I've got a Debian. It's either Ubuntu or Debian 64-bit thing installed on there. So it's working pretty well so far, and I have already tried wiring it and running it through USB-C. That works perfectly. So it's very promising, and it's very fun. I just love... I enjoy doing things the wrong way, quote unquote, because it's just kind of interesting to mess around and learn stuff. But yeah, so far it's working. I just need to learn a few keyboard shortcuts and stuff like that. But yeah, I'm having a good time. I also love, like, I just love the iPad a lot, right? So like on stream, I can easily switch to doing different things. You know, I've got the pencil, and I can, you know, make diagrams and whatnot. And, you know, it's like if I want to explain things like an engineer explains things, you know, I've got this digital napkin that I can scribble horrible drawings on and say, okay, if I do this, and, you know, like, I love that. The ability to do drawings on the fly like that is really nice. So, you know, I'm keeping my mind open to cool things to add and change about my stream that make it just kind of a cool way to present how I do my work and stuff like that, you know? Because I love programming, but I also want to bring a bit of kind of coolness value to it, or at least creative aspect to it, you know? And I don't know, I like drawing, so maybe stuff like that's useful. I have no idea. Nice thing about having a small stream in a relative niche like Clojure programming is that you can kind of just mess around, because it's not like you're going to be disappointing a huge number of people, you know? You want that for doing presentations. So much better slides. Yeah, so that's exactly the kind of thing that I think this is a pretty powerful approach for, right? Like, I mean, I could even do what's it called? Keynote. Right? Like, you get actual Keynote on here. Sure. So in theory, if I ever want to do presentation style stuff on my YouTube channel or on a stream, I can do this, right? I could have legitimate slides, but super easily pop over to a canvas, or I think you could even, like, bear with me, I'm just messing around here. So there's presentation mode happening on the stream, but I could do stuff like this. So you can draw in slides right away. Right? So it's better than good old-fashioned slides in general. And I can switch over to this if I have pre-made drawings or want to do something more detailed, and then can switch to this and do a live coding demonstration all in one go. So if I ever end up doing live presentations, this seems pretty cool. If I want to change up how I do certain videos and stuff like that on my channel, there's all kinds of options. But here I am blabbering about just weird hypothetical situations and not doing some programming. But that's why I like experimenting with this setup. I think the iPad is a really powerful, it's a really powerful tool. It's well designed, well made, fun to mess around with. Oops, that's not what I meant to do. It's just a little bit locked down from what I would love. That's the only thing. But with that Pi and a bit of design stuff, I want to make a little thing that holds the Pi on the back of my iPad and just have that as my workstation, on the go workstation. So we'll see how all that goes. Actually, all right, so now for this code here. So what I'm working on, I'm not sure if you know what FreeCAD is. Let's do this. FreeCAD. It's an open source 3D parametric CAD modeler. And it's just not displaying. The site's not displaying very well. Yeah, you got it? Okay, you know what's up. Cool. So, I already have a method where I could generate open SCAD scripts, and then open SCAD scripts I can load into the FreeCAD command line tool, and it can create a step file from that. So there's Clojure to open SCAD to FreeCAD. It's a 3-step thing. This is a first prototype rough pass at skipping the open SCAD emitter and just emitting Python scripts that run directly in FreeCAD and generate the 3D model using the Python scripting. So for example, I have this boilerplate. This is just the front. This is literally Python code I just put in a string. Like I said, it's a prototype. It's not like cleanly designed. It's just string manipulation at this point, but it's a good start. Then the 2D stuff, for example, this is just a rough code example, but here this def method writes an expression circle, and it emits the Python code that will actually generate a circle in FreeCAD. So I'm just messing around with that. Same with these things. And this is why I'm going to switch to my Mac in a few minutes, because I can actually run that on the FreeCAD graphical install, so that it's a little more to look at than just text. But that's what I'm working on. So this here, it takes... Let's see if I can remember how to actually do this, because it's been a while since I've looked at it. Let's do circle. I think that should emit... in the wrong namespace. Sorry about that. Using multi-methods? Yes, that's correct. So the current design of this library is a pretty direct copy of the SCAD CLJ by Matthew Farrell. So the design of this library, I like it because it's really simple. If we go into the source here, there's these important things to focus on: model and SCAD. So what's going on here, model is a bunch of functions that just emit Clojure data structures. In this case, that emits basically tags, and you can nest tags and all that. So here, for example, the function square with all of these arguments. Can I zoom in? Ooh. It just emits a list with a keyword square and a map of the arguments passed in. Same with circle. There's various things to do to merge arguments and whatnot, but it emits circle with the args map, and that's true for everything. So my model part of this copies that idea. The only difference is I use vectors instead of quoted lists, just because it was easier for me to work with. So for example, model 2D square, it's exactly the same thing. So in theory, you could use the SCAD CLJ model namespace to emit these structures without real problems. So in fact, let me try to switch to that now for a minute. Oh, I am in that. I don't know. Oh, of course. Here's the thing. I have to load file. But the multi-methods, which I'll get to in just a second, are a key part of this. So source model. Oh. Don't know what's going on. Okay, I'm going to switch soon, but let me finish explaining where the multi-methods exist. So let's have a look at, so assuming I made a model, it was working, right? It just emits the vectors with tags and maps. Very simple. Then here you go to the script emitter, and the biggest thing is this write expression multi-method. So def multi write expression, you give it a form that can be any nested structure of those maps, or pardon me, of those vectors with keyword tags and their argument maps. And then you can nest those into each other. And then this dispatches on, it splits, so it takes the first form and the arguments, and it dispatches on, if form is a keyword, it dispatches on that. If it's not a keyword, then we assume it's a list. So we give a default list expression here. So basically you've got the tags, and the multi-method dispatches on what tag you pass into it. That's all that's happening. And then you just write expression, and there's a helper function here, write block, that recursively will write expressions for any nested things. And these are, again, since this is my prototype just emitting some Python stuff, this design is taken pretty much exactly from SCAD CLJ. So at this time, I don't know if it's actually the best design, but it's a really simple design. It's easy to understand, and it's quick to follow. So if I can get this to work, it'd be really neat to kind of test if I can make Clojure that works with SCAD CLJ and works with the FreeCAD. Then using one source file, I can generate OpenSCAD stuff and FreeCAD stuff right away. That's the idea for this first prototype. So that's what's going on here. Hope that makes some sense. And while I'm just messing about here, I'm gonna pull this other computer of mine closer to me and maybe work on here instead. But before I switch that, I'll make sure things are actually going to work. Do, 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 do. All right, let's see. What do we have here? It does make sense. Using a similar approach at work at the moment, the fundamental structure is maps instead of vectors. Yeah, so that's what I mean when I say I don't know if this design is the design I'm going to continue with, because if you use a map, it kind of has a little more flexibility to it, because if you're going to be, you can rely on keywords being there or not, whereas a vector, you have to trust the order of certain things. Like it has to be the tag first and then the maps, right? The reason I don't mind that is because hiccup is pretty well known in the Clojure sphere. And hiccup has that vector, that tagged vector approach. So people are at least aware of that as an approach. So it's not so bad in my opinion. You use methodical in place of regular multi-methods. I actually don't know what methodical is. That's new to me. Clojure, methodical. And you spec everything religiously. So I've been, I have another library, SVG CLJ, and I have specs built for that because I need to learn how to use spec. Spec, I from what I'm reading and understanding, it's kind of a mixed bag for some people. But I'm still learning the ins and outs of it myself. So I'm not an expert, and I don't have a strong opinion on it either way. Just that I have to figure out the right kind of workflow with it for myself, if that makes sense. Let's see. Clojure multi-methods. CLOS, that's a common Lisp thing, right? It's a mixed bag. We might switch to Mali. Yeah, Mali is the one I'm hearing a lot these days. I haven't tried it yet. I think I might have to give it a shot. I'm gonna... Sorry, let me see if this works. I have... So I bought an HDMI switch. Yeah, there we go. Okay. And I'm slowly trying to make my stream cooler. I'm not quite there yet, but you know what? It's the thought that counts. It's the effort. Where's my mouse? Uh-oh. Oh. 1 second. I have to switch to a better scene. Hey, there we go. All right, so now I'm using my actual Mac, not just my iPad. And I'm just gonna close that for now. I can always switch back to it later. Good old iPad. These things, fantastic. Great form factor, love them. Once I learn how to develop my own apps for it, I'll make more Clojure tools on it and stuff like that. Oh, it's gonna be a dream. But I have to be careful not to overcommit myself. I don't know if I've ever asked you this before or if it's come up at all, but so you use Clojure at your work. If you're allowed to talk about it at all, what kind of stuff do you work on? I'm just really curious. It's always fun to hear what people are using Clojure for. It's a language I really love, but there's a lot I don't know about its use in the wild, you know? Build computational contracts. I'm going to be totally honest. I don't know what that actually means. Is that like crypto contract stuff, that sort of thing? Or is it a little more Nobody does. No crypto? Yeah, see, sometimes I get nervous saying I don't understand a thing just because, like, every once in a, so I'm a self-taught programmer. So every once in a while I'm like, if I admit that I don't know a thing, is that just me showing a huge blind spot, or is it like not a big deal that I don't know it, you know? But good to know that I'm not alone in not totally knowing. So you build software models of real commercial contracts. Okay. You're also self-taught. You're a lawyer by training. Oh, wow. Quite a change. But I guess it makes sense with the kind of software contracts you're talking about. It makes sense to have some lawyers on the team, I'm guessing. All right, let's see here. Let's go to Dev, FreeCAD. Did you are you happy to be a lawyer with where you do some software development, or is it like you found yourself in it and it just seems like an interesting combination. It seems unique. All right, let's see. Let's jack in. All right, let's have a quick peek at methodical while this boots up. You're very happy. Been coding since I was 11. Oh, I'm glad to. Oh boy, this is the perfect spot for my mic. Obviously not. I'm really happy that you're happy. That's great news. It's you know what? Not everyone's employment makes them happy, so it's really good that that's working out for you. Yeah, coding since you were 11. I probably started. So I've been using computers since I was a kid, but I didn't get a good opportunity to learn programming until I was probably in grade 9. So that would be 14 years old, I think, when I started. And honestly, it was after I graduated university that I really spent effort trying to learn a little more. So I've loved it for a long time, but haven't been doing it so thoroughly throughout my life. So maybe I'm just behind. ZX81 was your first computer? Oh man, that's so awesome. ZX81 computer. Looks amazing. Oh man, look at that keypad. That's that's like the keypads you see on like old CNC machines, you know? That the front pad just wears out and it's just like a small switch behind it. Love it. That's amazing. All right. Let's see here. Don't know if you know this about me, but I get distracted on stream pretty easily. I hope you're okay with that. I promise I can focus a lot more when I'm not streaming, but it's just kind of fun to just mess around and have a good time, you know, on stream. So fucked up keyboard. Yeah, it doesn't look comfortable. 1 kilobyte of RAM and 1 kilobyte of ROM. Man, that is a whole, like, that's a completely different world of programming. When you're working with such a restricted environment, that's you learn all kinds of different skills. That's really cool. I've never actually programmed on anything like that. I've been thinking it'd be really fun to get into learning old stuff like that on emulators and stuff, just as a fun sort of challenge and stuff like that. But I actually don't know where to start with that. Also, I probably shouldn't add more to my list of things to do. Yeah, those restrictions really make you creative. For sure they do. I think that's a paradigm that is really true in any kind of intellectual endeavor or creative pursuit. If you approach a thing with no restrictions whatsoever, I find anyway, it's almost impossible to start something useful. Like, it's way easier to start a thing if you are restricted, even if it's an arbitrary or artificial restriction. If you set some kind of boundary on what you are quote unquote allowed to do versus not, it's like your brain can kind of attach to that thing as it's like a seed for building out some kind of creative solution. The constraints really force creativity in every creative realm I've encountered, like building stuff, drawing, music, all that stuff. So it's actually kind of fun to work around constraints or build your own constraints, you know. If things are totally open-ended, some of the first things you kind of want to do is restrict yourself, at least for a bit, so that you have a start and you can expand from there. Model.cljc. I think there's a problem here. Unable to resolve R in this context. Line 103. I don't know what's going on. Let's have a peek. Let's see. All right, let's see here. Oops. Oh, this should be opts, not R. That was just a silly oversight on my part there. All right. I also want to do this. Zoop. So when you make a software model of a real commercial contract, like how does a customer end up using such a thing? Do they like log into a website and they read a piece of paper or like a document, or is it like a dashboard and they can click on different things? I'm having a hard time visualizing what kind of artifact is actually produced by contract software model. I'm confused because it's interesting to me, and I'm not smart enough to know what all that stuff means initially. Oh shoot, I've forgotten where that R problem was. This is me not paying attention to my own work. Search forward. Oh. I'm doing this the hard way because I refuse to do it the right way. There we go. Oh my goodness, I have problems. All right, let's see if that was the problem. Let's load it back up. There we go, fixed it. The goal is to make it easier to do contract management. So because we have a model, we can, for instance, tell you which obligations you have to fulfill, how and when, even if they're conditioned upon some events having occurred, or simulate the consequences of breaching a contract. Wow. That's fascinating. That's really cool. So the cynical part of my brain, reading that last part, simulating the consequences of breaching a contract, that sounds to me like the bean counters would say, all right, simulate how much money we could lose if we break this part of the contract. And if it's, you're going to lose 10 billion, but it's going to cost you 11 billion to fulfill the contract, it's actually cheaper to breach the contract. That's the cynical part of my brain. The optimistic part of my brain thinks, wow, that's actually really cool for, in general, for making sure a business actually upholds, or multiple businesses uphold their ends of agreements and stuff. There are the cynics out there for sure. Oh yeah, I don't doubt it. I don't want, I do my best to be pragmatic and optimistic. Sometimes those clash with each other though, so that's just, my head went to that. I'm not saying things are horrible. I want to try uphold the idea that we can affect the world in good ways. Truly. And I think that's a good thing. All right, so let's see if this is emitting stuff. Hey, there we go, we got something. The other side can do the simulation too. Make sure it'll not be profitable for you to breach. Yeah, that's a more game theoretic kind of approach to it, right? Game theoretic. In some real sense, it makes a lot of sense, right? Okay, you both now have the same capability to understand the contract more deeply. Therefore, it's in both parties or all parties' hypothetical best interest to be team players, right? And personally, I think there's a real benefit to that kind of thing. I am not trying to dump on your company or what you do, to be clear. I'm just talking about it because it sounds cool. Cool stuff. Okay, let's launch FreeCAD here for a minute, because I'm gonna start copy pasting Python to see if things will work. Didn't take it as such. All right, good. I hate to be misunderstood, especially online. That doesn't usually end well. I'm just a simple dev doing my simple work, trying to do the best I can, you know? Oh boy. There's not enough room on this screen here, I think. Hey, that's okay. We don't need to see all that much right now. Okay, so here is an empty FreeCAD thing. It's just unnamed. There's nothing going on. So I just have to remind myself how far I've actually gotten on this. Let's pop into the emitter namespace and we'll load that. See, this is the problem with my setup here. Yes. Load file. What did I call this? I did call it that. Cool. Can you pipe Python into FreeCAD, or is it cut and paste for now? Oh, so you can do I have let's show you here. So FreeCAD has a command line, so you can run a Python script right through the command line. So I could very easily make a Clojure call that just, like you say, pipes Python directly in. The reason I'm not doing that is because I am literally learning the Python required at the same time. So I'm just messing around. But so here, for example, if I type FreeCAD in the terminal here, it brings me into a Python environment. So I could do Oh, let's just do let's see. Let's do, I don't know what I'm doing here. Print. Okay, I have no idea if that's valid Python. I don't remember, but I can do this FreeCAD and pass a Python script into it, and if it were like a real script, it would actually read it and do a thing. I didn't do it right, but you know, whatever. So that works. How do I move this? You know what I'm gonna do? I'm gonna pop this over here and just let it be there. So here, that command line Python Repl is the same Python console. It's exactly the same environment that's right here. So if I emit, let's see if I can show you here. Write FCS. So let's do this. Let's just pass it in a circle, radius 20. Okay, so that's just a big string of Python code. Let's print line that. And let's just see, because I haven't touched this in a bit, unfortunately, so I have to kind of mentally refresh my own brain here. So I'm literally just going to copy paste this, but you can see how you could easily spit this to a file and run the file with a shell call, right? Like it's not going to be that hard to wire that up. In fact, it might make sense to do it just for testing purposes. But so I ran that. Doc recompute happened, and if you look here now, there's even a sketch added and a circle with the, sorry, I have to try fit. So there, it actually emitted a circle, which is pretty cool, if I do say so myself. Let's change this to a sphere. That's the first 3D object, because it's definitely the easiest one. Let's copy that, paste that, run it again, and there's a sphere, and it's legitimate 3D. So this is exactly how I'm working on making a prototype FreeCAD emitter. The cool thing about this approach in general is if I use the same model across all of these different emitters, I can use the same code to emit OpenSCAD, FreeCAD, and very easily I could make VBA emitters that you could load into Inventor and SolidWorks. So you could actually have an open source platform with open source tools that you can view everything and even like do parametric modeling with, and then work with companies that have proprietary software, for example, SolidWorks. And I think that is amazing. I think that's really a powerful thing because it doesn't force me to say to any company I want to work with, hey, you have to use my system. It's much more, hey, my little system will plug into the thing you already have and it'll work. So those are the gears turning in my head with this. So that's why it's fun to whip up these prototypes and get some good stuff going here. The interesting thing is to figure out. So I'm not totally happy with this model, right? Other than for prototyping, it seems good, but there's almost certainly more robust ways than literally just emitting different string manipulations, right? But as a start, it's pretty good. Sounds very cool. Yeah, I'm excited about it for sure. So the other, I probably don't want to load it into here, but as it stands, since I'm using the same model as the OpenSCAD stuff, once it works in FreeCAD, it will work in OpenSCAD too. So I'm getting 2 for the price of 1 kind of thing. The real tricks do come into place when different modeling packages have different semantics and different paradigms. So OpenSCAD is really good for creating meshes from Boolean objects, right? Like you can add and subtract stuff all together and stuff like that. FreeCAD has a lot of that as well, but something like SolidWorks, you have to kind of approximate certain things. Like you can make everything work together, but you have to be creative about meshing the semantics in a nice way so that it, from the person writing the code, they get out normally expected things from any package that they send it to. So it's not literally just, hey, just paste this code in. It's on my end, on the design of the emitters, you have to be thorough if you want things to actually make sense. But that's the value add, right? You don't want to have end users worrying about all that stuff. They want to write something once and run it on whatever CAD modeling package they use, right? That's the dream. But CAD packages are tough, no matter what. Okay, so I think I have all of these taken care of, although I don't remember for sure. Polygon. Oh yeah, that's right. So I made the square implementation, and it literally uses the polygon implementation. AutoCAD used Lisp for scripting. Yeah, it's called Autolisp. That's another interesting thing is, since I'm using Clojure here, you can also theoretically make a more transparent thing that, sorry, I just noticed a YouTube subscription. I'm getting distracted. What was I saying? Oh yeah, if you're using Clojure, right, like you can write macros that just change the structure of the code. Theoretically, you could actually make Autolisp from the exact Clojure code you write. Like there's kind of different levels at which you can connect your code to whatever CAD model you want. And one of the reasons I use Clojure is because I was originally interested in doing programmatic CAD with OpenSCAD and Python. Then I learned about Autolisp, and then I thought, oh man, maybe I should learn Lisp in general so I could learn the AutoCAD stuff. Then I looked into Lisps, and then I thought Rich Hickey's talk on, I think it was Simple Made Easy. It was just so compelling to me that I said, okay, I have to learn Clojure. And then I thought I'll learn Clojure well enough that I can build some CAD tools, and here I am trying to do exactly that. Okay, so what's the next smart thing to work on here? Let's do, that's not what I wanted, but no problem here. Let's see. Just trying to think what the smart thing to do here is. I think for right now, I'll actually put a little require in here and do FreeCAD CLJ dot model Refer all, I think, is safe in this context. All right, let's see. Okay, so now that is working. Okay, so now I can do print line, right, FCS, square, 3040. Okay, there we go. Nice high-tech copy and paste approach. I love it. Okay, so that is working there. So the reason I'm messing around with this is I want to see what kind of primitives I can actually make from various things here. Okay, so this is not quite what I'm looking at. Man, this is a little hard to use here, but that's okay. Fit all. So another thing that I want to keep in mind is I don't want to have to load up a heavy CAD package if I'm working on a small script. What I want is to have a quick viewer that auto updates when you edit the code. So I'm also keeping in mind, how I could use something like Three.js and React to make sort of a web view where you could do it kind of live and quick. Make sure your code makes the 3D model that you want, then you can save that code and run it in any environment and get out different things, not in a web browser or something like that. Because obviously interfacing with this isn't always convenient. Like you can tell I'm struggling right now. Okay. So this is not what I'm trying to do. Let's delete this. I'm trying to see if there's I think it's in the part design workbench. Yeah, pad I think is what I'm. Huh. Okay. I don't know why I have this here. I can actually move this out of here too. There we go. We do visualization of contracts, also generated with multi-methods, and we output reagent components and hiccup. Right, yeah, that makes sense. So I have, do I have a quick example that I could spin up? I won't launch it, but I'll pull open a thing here. So I do, I work on this SVG library that, yeah, here we go. So SVG CLJ, I have it on GitHub and stuff like that, but I use it for, where's main here? So shapes, I emit all of these shapes, circle, ellipse, polygon, all that stuff. And I have a DSL for path components. So move to Bezier curves, all that stuff. So I can generate pretty much arbitrary polygons and shapes. And I can transform them. I can do translate, rotate, and scale. Some of those things need a bit of work, but they generally work. And they all emit hiccup data structures. So you can pull this library in and use it to generate reagent components without any real problems. So yeah, talking about visualization with reagent, I know exactly what that's all about. And actually, so while I'm here talking about it, thinking about how I could use the library to generate timelines. Ah, cool. So by the way, this SVG library is the first one. It's the first library that I'm pretty seriously working to make a usable thing for open source. So if there are things that are totally not good or totally off, like if there's stuff about it that you think is good, stuff about it that you think should change, please feel free to open up issues, make pull requests, anything like that. There's a lot for me to work on yet. In particular, I need to get it to a pretty good state with reasonable documentation so that I feel comfortable putting it on Clojures. But anyway, blah, blah, blah. There's stuff that I'm sure there's things that I can improve. And if you're interested in using it, but it's not what you need, totally fine, right? It's an open source library. You do what you need for your work, but if there's feedback of any kind, I would love to hear it. So keep it in mind is all I'm saying. I don't know if you saw this, but this is on the right here. You can load the library up into a kind of working environment that does let you at the very least play around with some of the stuff. So I don't know how familiar you are with the library yet, but you can mess around with it too. There you go. I don't even know what this is. Just kind of a fun thing. A cool playground like Quill. Yeah, so it's a simple playground. I've used did I state it in here? Yeah, Quill is the wrapper library for processing, right? And P5.js. I bet they've got a little more stability around their stuff. Processing, yeah. What was I saying? This I built with clips, which did all the heavy lifting for me. It's a pretty powerful tool. So here, live demo. Right, so here, for example, it does more than Clojure, but it started with Clojure. There you go, live code snippets. Yeah, so this plugin I use to make a little web page to mess around with it there. So if I don't know, maybe that's a useful thing for you to mess around with. I don't know. All right, that's my little plug of my own work. I don't need that. I actually don't need this either. Let's pop back over here. Right, so this whole pad thing. That's not what I meant. Oh, you can edit the sketch. How do I Oh, I see. Oh, that did pop it in there. That's okay. Let's see. So here, these things turned this sketch into a body element, which I think should let a pad happen now. So pad selected sketch. Ooh, okay. Wait a minute. Why is it? Oh, I'm looking at it upside down, that's why. If you get to look at methodical, feel free to ask if you have any questions. It blew my mind when I realized how powerful it is. Yeah, that is something I'll have to look at. I'm not giving it a good shake right now. I'm distracted, but let's actually read the description for a second. Because I believe you. It's a library that provides drop-in replacement for multi-methods and adds several features. Next most specific method with next method. Oh, like you say, inspired by what's this stand for? Common Lisp Object System, I think. Is that what that is? Or Operation System, something like that? Yeah, Object System. Cool. This is a cool idea. Primary methods and auxiliary methods. That's fascinating. That could be very powerful. Their auxiliary ones are additional that are invoked before, after, or around the primary method. Huh. See this here? By default, methodical threads the result of each before method into the next method as its last argument. That is pretty cool. I'm going to have to keep an eye on this for sure. You know what? I'm going to do one of these. Boom. Now I'll be able to find it. That is really cool. Thanks for the point. What's the word? Recommendation. Thanks for pointing me in that direction. Do you ever have those days where you just can't come up with words? Am I the only one? I'm sure I'm not the only one. It's a half-brain day. Yup. Good, I'm not alone. Navigation. Touchpad. That zoom is way too ridiculous. Why? All right, this is not really helping me right now. There we go. Okay. All right, let's see what's up with. I gotta close this one down. Okay, 3D. Sphere works. I think cube is working. I mean, let's not think, let's try. Cube 30, 40, 50. Hey, we got something. It works. Why did this? Let's try that again. Don't know why that didn't delete the first time. Something went wrong, but whatever. That's okay. I don't want that. I want oh, VF, view fill. Good. I am actually gonna go to the washroom, so I will be right back. Let me set my status. Please bear with me. I will be like 2-3 minutes. Won't be too long. Here we go. Okay, let's see what's up here. What's going on? I hope so I have my window open for comfort. I hope the the outdoor noises aren't too distracting. If they are a problem, anyone watching, feel free to let me know, and I will close the window. I can't control the world. The world will do what it does. Let's get my chat window back open here. There we go. Okay, so I have some 2D stuff working okay. I've got 3D is where I need to work on some things next. It looks like sphere, cube, and cylinder all work because there's some built-in methods to build those up pretty quickly. Polyhedron is a different story, unfortunately. I might skip it. You know what? Actually, I will skip it because I'm kind of curious if I can create something like, well, let's do, I know. Okay, so I want to create a cube and a cylinder, and then I want to figure out a way to do a subtraction of the two. So let's emit just for simplicity, cylinder radius 10 is fine, I think, and a height of 50. Let's add that in. I should only have to copy this. Recompute. All right, so we've got a cube and a cylinder right there, and now I have to find what actually happens when I do a Boolean operation on those things, and I'm pretty sure that's back in the part. So Boolean operations on 3D solids are like cutting and gluing, basically. Edge from, oh, this will be exactly how I build up a polyhedron. Build up lists of vertices, edges, and faces, and then turn those faces into a shell and turn them into a solid. I don't want to do that right now because I am lazy, so I will do it later. Future me can do anything. Present me has to make choices. This is also not where I want it to be. I do love FreeCAD, but there is a lot of confusing design choice, I think. Now, to be totally fair to the FreeCAD devs, CAD software is complex. Like, there's a lot of functionality no matter what, and communicating it all through dialogues and stuff is not always easy. And you can tell, like, even I remember SolidWorks being a confusing mess to use sometimes too. So it's kind of an endemic problem with CAD software. You need to be an expert to use it, basically, is what it boils down to, which is a shame. Bit of a shame sometimes. Okay, there's got to be a Boolean thing somewhere, right? Maybe it was in part design and I just missed it. Additive, that's not quite. Oh, maybe these are create a pocket, create a hole. No, these are not it, unfortunately. Boolean. Okay, so I'm. Oh. I've gone and crashed the software. There's also those kinds of problems where it's not perfect software. Boom. Oops. I don't want to recover it, really. Ignore. Maybe the recover. Oh. Oh. It didn't do everything I wanted it to do. Darn. Name doc is not defined. Oh, right. Okay. So here, so the software crashed. It recovered the document, but the document itself, it did not recover the state of the Python console. It does not save the state of the console into the file you're working on at all. So that is not surprising, first of all. I mean, I would be more surprised if it did do that. But second of all, it is something to keep in mind if you're dealing with crashes. Again, when I'm actually doing this the way I intend, I won't have the FreeCAD GUI open. So if it crashes, it'll crash in a terminal, which is it's usually a bit easier to deal with. So I'll just make that fine. So let's have a little peek here. Ooh, let's see. Let's just mess around with some things here. Why don't we? I don't know if this will work, but let's do, not what I meant, my bad. Let's define A is just going to be a list of a cube, 20, 30, 40, and a cylinder with a radius of, you know what, let's do 30, 30, 30, why not? And the cylinder will have a radius of 10 and a height of 30. Okay, so A is those two things. Let's see if write FCS will work on A. It does not. The reason for that is what? Let's do write expr of A. Okay, good to know. Things are not working yet. See, this is the fun of prototyping your ideas out in code. I mean that genuinely. I don't mind that I hit errors. I mean, I expect it. It's just fun to learn. There's kind of two things I learn. I learn the bits that just don't work, and I learn the functions and functionality I actually want as I'm using it. Like, I want to be able to emit something that just has a list of objects in it. And I don't necessarily know that up front until I'm like, oh, I want to use it this way, but it doesn't exist. So you kind of iterate, the implementation with the actual desired usability of it kind of wrapped together. I think that makes sense. I'm sure there's like proper names for that kind of approach, but I don't know them, and I just call it iterative more than anything else, really, because that kind of is all it is. It's nothing special. It's just a fun way to work. Okay. So I kind of thought that this would happen here. So the form, in the case of A, the first item here, it would destructure the form as this whole vector. So it would be a list. So what I thought would happen is this function here, it would return the form if it's just cube or whatever, but it would return the keyword list otherwise, and then it should do this. So here I can simulate it by doing mapcat write expression. I think I might have also written this wrong, but I'll see. Whoa. I mean, that is wrong, but that is cool. Let's just do map write expression over A. So there we go, kind of. But that's also not what is failing, right? It's what am I missing? Do, 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 do. What is A? Missed it? Oh, yeah, sorry. I'm distracting myself. Give me 1 second. I will... there we go. A is... I do this a lot. I define A in the REPL as just a sort of transient test thing. A is a list, or a list, loosely speaking. It's a vector of cube and cylinder. So I defined A this way. Let's see here. It should be in the history. Def A as a vector of cube and cylinder. And to be fair, I actually could... let's do it again. List cube 30 30 30 cylinder 10 30. Oops. Oh, silly me. So there we go. Now it's a list of vectors. And how is it failing? If I do write expr, or yeah, so it gives a null. And if I do write FCS, same thing. So I think it's not... I think what's happening, you're getting a Stack Overflow, because I think it ends up getting put into write expression, then it gets tagged as a list, but all that does is, I don't think it's destructured properly. I think it ends up just passing itself to itself infinitely. I think that's what's going on. But I haven't applied my brain much more thoroughly than that to the problem. So what I'm playing with here is this line here. If I do map cat write expression to A, right, it maps and concatenates everything. So since they're two strings, it'll just concatenate every character of the strings. So that's not quite what I want. I actually want apply string to map write expression of A, and that should make a single string kind of with what I want. Although string/join with a new line character would actually be even better, because here print line yeah, so it does all the cube stuff, and then it places it, and then it does all the cylinder stuff. So this is the exact kind of output I want if I pass a list into the right expression form. But I don't want to have to manually do it that way. I want it to properly dispatch itself, and that I don't know. I don't know why that's not working yet. So I'm trying to just wrap my head around that briefly. So this here, I want to define this. Let's see. Let's do this form and args. keyword form. If it is a keyword, then form otherwise list. Okay, so if I do ASDF of A, it does return list. Right, so this shouldn't be args really, it should be forms is more likely to be correct. So maybe okay, right, I know this, I know I want this to be what happens, so why not just put it in and see if it works? Let's give it a shot. Actually, let's do this. Oops. So I before I moved, I didn't use any structural editing, par infer, par edit, or anything. So I have I run par edit now, and I'm still getting used to it, and I still don't know all the keyboard shortcuts, so I'll still fumble around a bit, but I am getting a little bit better at getting used to it, auto completing, you know, other things for me. So I still have a lot to learn, but it's getting better slowly. Unbalanced parens, of course. See, that's what I mean. I still don't know why sometimes things don't work like that. It should. Is it this? I hope it's not that. I don't understand. Where are the unbalanced parens, please? 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 Oh, wait, what? Oh. See, I don't know why that happens. Okay, let's try this now. So right expression of A seems to work. Now let's do write the whole script of A. Okay. Print line, write FCSA. It has cube and cylinder in there. It's promising. Let's see if it actually does something. Indeed it does. Hey, wow. Hey, wow, I solved the problem. Let's make sure to save that. Oh. We're at the clipping distance here for some reason. What? Why is it doing that? Oh, let's do VF, please. See that Z fighting there? Love it. Okay, now we're on to trying to get things to work. This might crash it again. Let's find out. No, it was here. Okay. Hey, it didn't crash. That's good. I don't quite understand. Okay. Ugh, what? That's not what I want. Okay, well, let's try. I don't love it. But okay, let's see. Let's see now. Maybe I can do... Oh no. Cancel, please. Let's do this. Okay. Remove. It didn't do anything? I don't know what's happening. Right, so Boolean operations currently confuse me, but I have to figure it out because I need it to work. Oh wait, let's cancel this. Let's undo. Okay, so we've got some base feature. Let's see. Maybe there's tutorials. Let's see what's going on. Yeah, so this is a Boolean cut. That's what I want to happen, but I need to know the code that is emitted in the Python console to do it programmatically. Okay, so make sure nothing is selected. Activate the body. Let's see what this is about. I think I'm gonna have to slightly rethink how I currently programmed the sketches and the simple solids. I think I have to wrap everything I add into its own body. Maybe? So I'll have to figure that out. But okay, let's see here. The first thing to pay attention to is let's go back. It's important that neither the active body nor any of the features it contains be selected. I don't understand exactly what that means, but let's pretend that we do and try things out. How about that? Okay. Wait, what? Why can't I see? Oh. That's weird. Okay, that's good. This is not. Let's delete this thing. Let's turn this into a body. Hide that one. Okay, so now I've got something a little bit better. There's not accidentally duplicate things inside things that I didn't expect. Let's see what we can do. Okay. What? Don't know. Don't know what's up. I don't get it. Okay. Okay. Let's try one more time. Okay. Activate body A, and body 001 will be the tool. Okay. Let's do this. Remove that one. What? What? Okay, things are... I don't get it. All right, let's have a look at what kind of code's emitted here and see if we can kind of piece together a bit of logic here. So I definitely need to figure out what kind of what this even means. A body. Okay, body concept. Perfect. So part design body is intended to model a single continuous contiguous solid. Element made in one piece, no moving parts. So it's a contiguous solid, any manufactured from a single piece. Nut, washer, and bolt. Yeah. Okay, this makes sense. Okay. It's starting to make a little bit of sense, but it's not completely. So I also want to have a look at the part documentation. I wonder if there's another Boolean operation with part that I could use for prototyping purposes. Oh. Interesting. Mirror, fillet, chamfer. Oh, they're right here. There are Boolean operations. What's going on? Okay, let's take a few steps back here. The part design workbench is more complex than the part workbench. So I'm going to focus in on just the part workbench for now and see how that goes. See what kind of stuff I can still make work for me. Okay, so in order to do that, where am I at here? There we go. Let's do clear doc. That's weird. Okay. Let's clear this console. Let's paste this thing in there so we have that basis. Okay, we've got a cube and a cylinder, and let's recompute the doc. There we go. Let's get out of the part design thing and work on just the part bench here. So I think part of the issue is I'm not seeing, I'm not looking through all of the buttons. I'm missing some. Oh, here it is. There we go. This is exactly what I'm trying to get at. So let's do a difference. Apply. There we go. This is exactly what I was looking for. Much simpler, much more straightforward. Okay, so right. Let's have a peek at how this works. All right, these are the relevant lines that were put into the console when I went through the dialog box. So the right set of instructions are basically all right here. And let's see. Okay, so this is the first thing. Add object, part cut, named cut. Cut.base equals something. Cut tool equals the some other thing. So add a cut, define the base of the cut and the tool of the cut as equaling the two shapes that you're passing in. And then you hide the two tool shapes. And then you I don't know what these last two things do. Cut.shapeColor equals GUI.ActiveDocument.cube.shapeColor. Okay, so that's just whatever. For the very basic prototyping, let's ignore that. Then here, display mode. You match the display mode of the tool shape to set the, so the shape color and display mode are set based on the tool base. So it's just copying those pieces over. I'm gonna close this window now. I'm actually a little bit cold now. All right, so let me copy this. Let's do some split here. What? Why not? Can't splice top level. I don't know what that means. Oh, I have a conflict with par edit. Oh well. Okay, that's just gonna have to be fine for now. Okay. Let's have a look at SCAD CLJ. I think probably I'm gonna get going in about half an hour at most. Feeling a little. These are all clones or forks. All right, what am I looking at here? Okay, Boolean operations is the section right after transformations. Okay, so let's just call this Boolean ops. Bool ops. Okay. Boolean operations, and the first one is, let's just start with difference because it's kind of the coolest looking one. It's the one I think I probably use difference the most with CAD design because you end up cutting a lot, but you don't necessarily end up gluing. Well, no, that's not true. Union and difference are probably equally used, but difference is a nice, cool thing to see happening. So let's give that a shot. Let's do first of all, let's paste a little difference takes 2 elements. The base and the tool. The base is what remains. The tool is the section that gets cut away. Yeah, so paste some of this garbage in here and clean it up so it's a little more readable. So here I can do doc.addObject part cut, and we give it the name of cut here, which I'll change, but that's fine. Doc.cut is the name. So let's make that a little clearer here. Cut name like that. And here, this is going to be, this I don't know how to do yet, but when I run this, I will need to know the names of the child elements of the cut. But the names are currently being gensimmed, so they're not important, they're just unique. So, or they are important, they're arbitrary though. So I need to make sure, excuse me, sorry about that. I need to make sure that the constituent components are generated first, and then I do the difference, having called the names of them. So I'm almost certainly going to have to rethink the approach here, because I don't want to have to generate strings and then read the strings I generate. I want everything to be in a simple data structure first, and then just do the string generation at the very end. Make it as straightforward as possible. So I'll probably have to rethink the approach here, but let's just go forward and see what I come up with. First, so cut name dot tool. So these are the two things. There's base and tool, and they'll each have something here. Doc dot the name of the thing, doc dot the name of the other thing. Yes. Then these dot hide things, I guess, are important as well. And these ones, I don't know, these are a little less, but I guess they're not that hard to add, so I should probably keep it in there. Right, so doc dot cut name, display mode. Oh, these I actually don't want to use because yeah, I think I'm going to get rid of these, because in the context that I'm actually going to be running these scripts, I can't open the GUI anyway. So GUI, GUI, don't know the proper pronunciation for that, but let's call that good. I hope I'm not missing anyone's messages or anything, by the way. I hope they seem to be working. Let's see. I'm still here, but I think I'm running closer to the end of my stream for the day because I'm getting a little too distracted. So let's keep moving forward a little bit here. I think I should hopefully be able to get a little something going here. Have to dash 2. Hey, thank you so much for tuning in anyway. I'm gonna see if I can make just a little bit of progress on this Boolean thing, but not much going on in my brain right now, so thanks for tuning in. Hopefully I'll see you around, by the way. I really love streaming. I'm gonna keep doing it now that I'm settled in, all moved and stuff like that. You should expect to see my streams a little more frequently again, but it's always really encouraging to see people still interested even after I took some time off. So thank you so much for chatting today. I appreciate that. Keep it up. Yeah, I hope so. It's so much fun, and I think with the right effort, the right feedback with the community, I think I can build the channel and the interest and get a little more momentum and all that stuff. I don't want to be overly dramatic and excited about building a community, but I think we can do it, with a bit of patience and stuff. So I will keep it up. This short response is, yeah, I'm going to keep it up for sure. Okay, let's see. Let's get just a smidge done with this Boolean thing and see if I can get something cool done for the day. That'll be me. That'll be the goal. Or I'll quit in half an hour at the very least. Oh, so I am getting a message from family. Let's see what's up. Mm-hmm. Hmm. Oh man, I'm getting messages from my brother about his thesis work and stuff like that. It's having a tough go of things, so just sending him a message of care, I guess. Let's see here. Oops. Let's reply to this. There we go. Right. Okay. Let's write a little bit of a function at the very least, huh? Let's do difference. I think in Open SCAD, I don't remember what it is. Let's go to the Booleans. Union, intersection. Yeah, difference does exist. Okay, good. So let's take define difference to be and block. Yeah. I'm in the wrong thing as well. Let's go to, oops, no, I want this. Let's go SCAD. Yeah, here. We've got okay. Let's call it forms here. It's a little clearer in my head. So I'm gonna just, for simplicity for now, I'm just gonna send or assume that this is gonna take just the two forms. The first form is gonna be the base, the second form is gonna be the tool. The forms are inevitably going to be passed in as like once they get to this. Wait, I do have, the model does have difference in it, right? Oh, I'm doing this wrong. This has to be def method write expression for the difference keyword. That's what I actually need it to be. And let's close that. It has the form like this. Oops. The model Boolean. Let's change this to forms. Here. Forms. 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 Right, okay. So that's no problem. Here we have the same general approach. Let's change this up here. Let's do this. This actually, for right now, it doesn't need anything. It's going to have a key that says difference and an empty map as the two arguments that come in. That's not, no, that's a little bit wrong actually. Sorry, let me, oh right, so this is different than, so a sphere for example has key, map, nothing. This has key, map, forms. Oh, this is missing, this is not good. That's weird. Don't know why. Oh, maybe when I replaced block with forms, maybe I messed something up there. Okay. So it does have one thing, so it's like this. This one will have forms. There we go. Now we've got everything we need. So the forms coming in at this point will be in the shape of something like this. They'll be cylinder with this. So they will not be in the string form, but I want this whole thing to emit as a string. So what I need to do is effectively map forms, which should be a list, right? So I should be able to do string join with a new line. The result of let me think about this. Okay. This is what I'm gonna do. I'm gonna oops. Okay, I'm gonna define a function here called get name, for lack of a better thing, and it pass in a string, and that string is going to be something in the shape of this. So we need to come up with a regex that will match the first little bit of this. So let's see. If I define, let me just do, let's imagine this. String, let's define B as this string. B is this whole thing. Split lines. Okay. First of that split this on the regex equals sign first of all of that, and then trim, right? All of that. Okay, let's just turn that into a nice little thread macro here. Thread S through split lines, which won't need this actually. Split lines. Oh boy, I gotta go to the washroom again. I will be right back. come on. Where's the scene? There it is. All right. Okay. I gotta focus up and get something going here. So this here is going to be a getName function that gets the names that I need to put into the difference thing. Should theoretically work. We'll see if it does. Okay. Let's go. Let's go. Let's go do it. Okay. All right. All right. So pass S through split lines. Then you pass it through first. Then you pass it through split with the regex equals. Then you pass it through first again. Then, oops, don't need that, string trim. Then you see if it works. GetName B seems to work. I'm going to assume it'll work for the time being, and then we can go from there. So here I can copy this let block as a starting point. Let's paste that in there. Oop, I messed something up. There we go. Okay. There's a let block. Looks good so far. Okay, so the name is just going to be gensim difference. Is good. The position we don't need. Base is actually going to be getName of first form I actually need to do something kind of like this. So base and tool are going to be the results of map write expression on forms. Okay, so each form is going to be turned into its string, and that's all fine and good. Then I can use that, so I could do base name, right, is getName of base, simple enough, and tool name is getName of tool, because those are both strings at that point. Then, using all of that, what I can actually do is string slash join with new line the all of these bits here. So we've got base, and then we've got tool, and then here's the more interesting stuff, which is going to be all of this basically. So it's going to follow this pattern. Basically string, blah, 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 blah. Yeah, this should work. So we do it here. Let's actually do this a bit. string name equals doc dot add object part cut so, right? Yeah. Cut name. It's a little confusing. That's okay though. Then a new line. Okay. Then name dot. Right, so as I'm writing this out, I think it makes sense to build a map data structure that I build up with these kinds of things as keywords, and then I just have a string emitter function that works over all of those maps for every one of these. That way, or to be a little maybe even better about it, the model part of this I can put into the maps all of this stuff right away, so that I can actually, when I write expression, all of the necessary data is already computed in the map, so I'm not bumbling around with these weird lines and things. That's probably a smarter approach, so I'll have to keep that in mind for a V2 V2 prototype. But I will go on. Right, so here we've got name dot base equals doc dot base name, right? Doc dot base name. Yes, that's correct. Followed by a new line. Then here, name dot tool equals, doc dot tool name, new line. So that's these here, and then these I should do as well, and that'll be here. Now it's doc dot hide base name doc dot hide tool name Okay, let's see if that makes any sense whatsoever. Right, let's do difference between, wait a minute, let's do A. Ooh, let's do apply difference to A. Don't think that's correct. Or is it? Oh, it is. Let's do it this way. Cylinder. Oh yeah, it ends up being the same. Okay. Right, let's try right expression of this. Ooh. Now let's see if it works. Let's def A. So A is a new thing now. Write FCSA. Perfect. Let's now do print line, write FCSA. Let's see if this will generate something correct. Let's do a clear doc. Let's paste that in there. Ooh, not quite. Okay, so what's gone wrong here? Missed new lines. Let's see if that's all it is. That's the only one I need. I don't need one here. Let's do this again. Okay, let's do clear doc. Clear this console. Let's send this over one more time just for safety. Let's see now. Ooh, almost. Something app.document has no hide. Okay, so I did something wrong here. Maybe I don't need the hide parts of that. This is exciting. Let's clear doc. Okay. Clear the console there. Let's comment out, well, let's actually just get rid of these. Let's try this one more time. Yes, it worked. Okay, that's very exciting for me. I'm happy with this. Let's sanity check that this works. Let's define A to be one other thing for a minute here. Def A, please. Let's give this cylinder's radius a boost. Okay, so that we have something different. Let's do this. Yes, it works. Okay. That is a great place to end, if I'm being honest. I'm very happy with this. Okay, thanks so much everyone for tuning in. If you're watching this on the VODs channel or on a VOD or something like that, please consider following this channel, following my YouTube channel, all that sort of stuff. I've got, hey, for anyone who happens to be able to see this, I'm going to pop my YouTube link in the chat. YouTube. Okay, that's that. Let's see if I here we go. This is my channel. Have a look at this. I'm really excited to be posting videos on here. I love it. This is my latest one. When I just moved to Vancouver, I explored Stanley Park a little bit. I do function showcases. I do little builds like CAD builds and stuff like that. Sometimes make little apps. If you're interested in that sort of stuff, please consider giving this channel a look. That's going to be all for me today. I am gonna sign out. I hope you have a good day, and I will be back again tomorrow. Bye-bye.